Hi everyone. I will be presenting the computational thinking in Python workshop today together with Bunhao and Prakash. So first, let me share my screen first. Can everyone see my screen?
Oh yeah, can you make it full screen?
Okay. Yeah, everyone can see the screen, right?
Yeah.
Okay. Okay, let's start. So good evening, everyone. My name is Tensi, and today, together with Bunhao and Prakash, we are proudly presenting to you the computational thinking in Python workshop. So here is the flow of the program for today. First, we will start off with Kahoot Quiz to test on your Python skills. And next, followed by a brief introduction and explaining about what is computational thinking. Next, I will explain the 4 key concepts of computational thinking, which involve algorithm, decomposition, abstraction, and pattern recognition. So without further ado, let's start with our first program, which is the Kahoot Quiz. I will be sharing the link with you all, so give me a minute. Everyone, please feel free to join the Kahoot.
Hey, want to get into the world's best universities but don't know where to start?
Okay, we will start around at 8:12, so 1 more minute for those who haven't joined. All right, let's start.
First time doing it. Why is everyone so
Sorry. I think someone is unmuted.
Yeah, for the question, right? Actually in Python 2, there was an internal limit to how large an integer value could be, but the limit was removed in Python 3. So this means that there is no explicitly defined limit, but the amount of available address space forms a practical limit depending on the machine Python runs on. So let's move on to the next question. The plus operator concatenates strings, and the asterisk operator creates multiple copies. So the result of 2 asterisk bracket s plus t is full bar, which does contain the string buff. The ORD function returns the integer value for a given character, but you can only specify a single character, like a string of length 1. You cannot use multiple string and find the ORD. It has to be character by character. So variables need not be declared or defined in advance in Python. To create a variable, you can just assign any value to it. So variables are not statically typed in Python as they are in some other programming language. So for the question just now, the first statement creates an integer object with a value 300, and n is a reference to it. And the second statement creates a second reference to the already existing object. So right, for for loop, right, actually for loop only accepts integer. So just now inside the for loop, it's float object. So the program will execute with errors. So congratulations to the top 3 winners for the Kahoot Quiz. It shows that you all have a deep understanding of what Python language is. So let's move on what is computational thinking. So what is computational thinking? Computational thinking allows us to take a complex problem, understand and what the problem is, and develop possible solutions. So to put it in simple terms, it's basically just problem solving. And more specifically, computational thinking is a set of skills and processes that enable us to navigate complex problems. While this methodical approach is derived from the process used to develop code and to program applications, computational thinking can be much more broadly applied. Computational thinking is a map from curiosity to understanding that make it easier to tackle both large and small problems. So why is computational thinking important? Computational thinking is important as its ability to navigate complex information and to think in a way that complements technological processes, which is essential to human readiness. As a foundation for coding and computer science, computational thinking encourages us to reflect clearly on the problem we are solving for and intentionally program solutions for it. And as a foundation for technology integration, Computational thinking encourages us to consider how we can leverage technology to aid us in solving these problems, such as to automate certain tasks. And also, computational thinking encourages us to be diligent and organized in our work, to plan from the outset how we want to solve the problem, but to embrace the fluidity of the process as we come to more and more understanding of the data and information we are navigating. So it's also about finding the best solution that solves the problem correctly in a faster way and using the least amount of resources. So let's take a look at a short video to dive you deeper on what is computational thinking.
Computational thinking. What is it, and why is it so important? Let's start by looking at the what. You may think that computational thinking is about thinking like a robot or programming like an expert. But it's not. Rather, it is a very versatile skill, a skill that focuses on critical and logical thinking. To put it simply, computational thinking is a problem-solving skill. Let's dive a little deeper. Computational thinking is about looking at a problem and solving it systematically, and therefore arriving at a solution that both humans and computers can understand. Essentially, it is considered the highest order of problem solving. Computational thinking is made up of 4 elements: decomposition, pattern recognition, abstraction, algorithmic thinking. First of all, decomposition. Decomposition is about breaking a difficult problem down into simple and easy-to-manage parts. Second, pattern recognition. Problems come in all shapes and sizes, but amongst their many differences, there are bound to be similarities. Pattern recognition is about spotting what different problems have in common and using what's worked before to help you out again. Third, abstraction. Abstraction is all about focusing on the details that matter while ignoring the ones that don't. By applying abstraction, we can cut through fluff to get to the heart of the matter. Finally, algorithmic thinking. Algorithm is really just a big word for a set of rules. So algorithmic thinking is basically when you generate a series of simple steps Moore's law, computing performance doubles every 18 months. And based on past experience, Max, he's your average hardworking young man, trying his best to be a productive member of society and using what's worked before to help you out again. Third, abstraction. Algorithmic thinking is basically when you generate a series of simple steps that anyone can follow to solve a problem. Now, let's bring everyone together with a simple example. Meet Max. He's your average hardworking young man, trying his best to be a productive member of society. But today, Max's car has broken down. Luckily enough, he's computational thinking enabled. Let's see how he solves this problem. Max's car can't move too well. He realizes that there are 2 problems. He's running low on fuel, and he has a flat tire. That's the first pillar, decomposition. Now, Max has been in a similar situation before, and based on past experience, he knows that he should take care of the flat tire first. That's the second pillar, pattern recognition. He doesn't have much fuel left, but it's enough to get him to the next patrol station. So he decides to ignore that and focus on the tire. That's the third pillar, abstraction. Finally, to change a tire, Max has to use a jack to elevate his car, loosen the nuts on his tire, remove the tire, and replace it with a new one. Now that's algorithmic thinking. As you can see, computational thinking isn't just for computer scientists or programmers. In fact, many kinds of people, from mechanics, doctors, to presidents, are subconsciously applying computational thinking in their daily lives. Thanks, Max. Have a nice day at work. So why is computational thinking so important? It's not. That is, if you don't mind being left behind in the Stone Age. According to Moore's law, computing performance doubles every 18 months. That is to say, in 10 years, a $1,000 computer will be able to compute faster, more efficiently than the human brain. With technology growing at such an exponential rate, we are integrating computers more than ever before into our lives to connect, to optimize solutions, and most importantly, to solve problems. The possibilities are limitless. The problem is, having a supercomputer carry out basic instructions and tasks is not at all economical. To make full use of a supercomputer, you'd need to know how to give super instructions. This is where computational thinking comes in, a powerful way to generate advanced solutions and manipulate computers to work for you. Now, imagine if mankind had such immense power at our fingertips. We would be solving problems faster than ever before, with laser accuracy and machine efficiency. With computational thinking and supercomputers, the dream to tackling titanic problems, such as finding a cure for cancer, can be a reality, pushing mankind beyond the final frontier and boldly go where no man has ever been before.
Hope you guys enjoy the video, and I hope you all have a more understanding on what is computational thinking after watching the video. So from the video, I'm sure that you all now know that there is 4 key concepts in computational thinking. The 4 key concepts are decomposing, abstraction, pattern recognition, and algorithms. Let's look at abstraction is basically generalizing patterns, focusing on the important information only, ignoring irrelevant detail. And next, decomposition. Decomposition is breaking down a complex problem or system into smaller and more manageable parts. Pattern recognition is identifying patterns and trends, looking for similarities among and within problems. And lastly, algorithms, which are developing a step-by-step solution to the problem or the rules to follow to solve the problem. So computational thinking involves taking the complex problem and breaking it down into a series of small, more manageable problems. And each of these smaller problems can be looked at individually, considering how similar problems have been solved previously, and focusing on only the important details while ignoring the irrelevant part. Next, simple steps or rules to solve each of the smaller problems can be designed. And finally, these simple steps or rules are used to program a computer to help solve the complex problem in the best way. And the process starts with data as the input, and through a series of steps, we, like the computers, process the information and produce some sort of output to the problem. What makes this especially different from other problem-solving processes is that in the end, results in an algorithm, which is a series of a step or a person or computer uses to perform a task or solve the problem. In doing so, computational thinking ensures that the process can be replicated. So the 4 key concepts that I've just mentioned is act as a cornerstone and is as important as the others. So they are basically like the legs on a table. If one leg is missing, then the table will probably collapse. So each and every concept is very important in computational thinking. So first, let's take a look at what is an algorithm. So an algorithm is like a recipe. It must be followed exactly, and it must be unambiguous, and it must have an end. So it's a precise and sequence of steps to solve a problem. You can't jump any step or procedure in between. So let's take a look at the picture on the right. This is an example of a recipe of making a pancake. So let's take a look at this algorithm. So first, we will measure the pancake mix. And next, step 2, we will add water to the pancake mix. and after that, we will mix well. So now we have to determine whether it's spreadable or it's too thick. If it's too thick, then we'll move back to step number 2 and add water again, and followed by mixing. And if now it's spreadable, then our problem is solved. So this is basically how an algorithm looks like. So an algorithm is a plan and a set of step-by-step instructions to solve a problem. And also, algorithm should generate a solution. However, the solution may not be the best solution to the problem, and it also may not be the efficient way to solve the problem. So oftenly, we tend to create more than one algorithm, and we find the best and most efficient algorithm to solve the problem. So let's take a look at how to design an algorithm. First, we have to determine the right steps. Next, we have to determine the correct order of the steps. And we must follow the steps completely. And we have to verify whether our algorithm is working correctly. And lastly, we have to determine if this algorithm is the best approach for solving the problem. So let's take a look at an example between brute force versus divide and conquer algorithm. So here is an example. What is the algorithm to search for Mike Shepherd's phone number in a phone book? Let's take note that the names are sorted according to the surname. So we will look for Shepherd in the phone book. So I will give you guys a few minutes to think, what's the algorithm to approach this question? Okay, I'm sure that you guys already know like what are the right steps to look for the phone number. But however, let's take a look at the algorithm to solve this question. First, we will look at the brute force algorithm. So step 1, we have to open the phone book to the first page of the name, where the page is begin with the surname A, alphabet A. And next, step 2, we have to check to see if the name Mike Shepherd is on the page. Step 3, if the desired name, which we are looking is Mike Shepherd, is not on the page, then we will go on to the next page and repeat step 2, which is to check if to see the name Mike Shepherd is on the page. If the desired name is on the page, then we will write down the phone number and stop, because we have already solved the problem, which is to find Mike Shepherd's phone number. So this is basically what the brute force algorithm is. Look through page by page until we find Mike Shepherd's name and we write down the phone number. So are there any other ways to solve this question? Yes, we have one more, which is the divide and conquer approach. Okay, before we look at the divide and conquer approach, let's dive deeper into what is brute force algorithm. So for the brute force algorithm, notice that we have a conditional statement, which is the one I highlighted in green, the if, and then. The if and then statement, which allows us to determine if we are done or if we have to go to the next page of the phone book. Also, we have a loop, which is here, the repeat loop. If we did not find our desired name, then we keep repeating step 2 and step 3 until we find the name Mike Shepherd. So let's take a look at the divide and conquer approach. So step 1, we have to open the phone book to the page in the middle. So different from the brute force algorithm, now we start to open our phone book from the middle. And step 2, we have to check to see if the name Mike Shepherd is on the page. So we open our book from in the middle, and then we check whether Mike Shepherd appears on the middle of the page. Step 3, if the search name is not on the page, then if the surname on the page begins with a letter before S, then we will ignore the first half of the phone book and continue searching after the middle page and repeat from to step 1. Or if the surname on the page begins with a letter combination after S, then we will ignore the second half of the phone book, continue searching before the middle page and repeat from step 1. Or if the desired name is on the page, we will record the phone number and stop because we are done. So to have a better visualization of what is divide and conquer approach, I've come up with a diagram. So let's take a look at the steps again. So step number 1, we have to open the book on the middle to the page in the middle. So this is a phone book from letter alphabet A to Z. And when we open from middle, it starts with alphabet M. So now we have to check to see whether Mike Shepherd, the surname, is appearing on the middle of the page. So clearly, S is in between M and Z, which is not on the page. Then we'll move on to step 3. So if the surname on the page begins with a letter before S, then we will ignore the first half of the phone book. So now we can ignore the first half of the phone book as letter S appear after the middle of the page, which is in between M and Z. So now we can ignore A and M. We just throw away the first half of the book, which looks like this. Now we just need to find between M and Z. So between M and Z, we repeat the steps again, which is open the middle of the book from M to Z. And now the alphabet between M to Z is S. And S is the surname of the first letter surname of Mike Shepherd. So now we have found our desired name and we can write down the phone number of Mike Shepherd and we are done. So here's another example, which is binary search and linear search. Binary search is equivalent to the divide and conquer approach, and linear search is similar to the brute force algorithm. So for brute force, for linear search, if we want to find G in the sorted list, we have to go through sequentially one by one, from letter A to letter B to letter C. And we cannot jump the steps in between. We have to look one by one until we found our desired alphabet, which is letter G. So there's 7 comparisons if we use the linear search. And for binary search, which is the divide and conquer algorithm, if we are looking for G in this list, we only need to do 3 comparisons. So we start from the middle, which is letter I, and we check to see if G is less than I or more comes before I or comes after I. So if now we know that G is definitely before I, we will ignore the second half of the list, and we start our search in the middle again, which is letter E. And now we compare again whether G is before E or after E. So G is now after E. So we ignore the first few parts of alphabet in the list, and we open the book from the middle again. And next, we will find our G, which is in the middle. So total, there's 3 comparisons. So clearly, we can tell that binary search is much more efficient compared to linear search. As linear search, we have to compare one by one. And it shows that we have 7 comparisons in order to search the letter G in this list. And for binary search, we only need 3 comparisons, and we can find our desired alphabet, which is letter G in the list. So I have come up with a diagram to show you the comparison between brute force and divide and conquer. So the amount of work for the brute force, you can see, is linearly increasing, while the divide and conquer is much more efficient compared to brute force, as the amount of work required for divide and conquer algorithm, as you can see from the graph, is much more lesser compared to the brute force algorithm. Next, I will start off with another key concept, which is decomposition. So what is decomposition? Decomposition involves breaking down a complex problem or system into smaller parts that are more manageable and easier to understand. So this is a famous quote by the famous mathematician George. So what he says is that if you can't solve a problem, then there is an easier problem you can solve, and you just need to find it. So by breaking the complex problem into smaller parts, you will able to be easier to understand, and eventually by solving the smaller parts, you're able to solve the complex problem. So let's take a look at the diagram on the left first. So let's visualize together. We have a complex problem. Then we break it into sub-complex problem. We break it down even further to even more sub-complex problem until it's easier for us to solve it. So to illustrate this diagram, I have to use a picture on the right. So now we have a complex problem, which is to make breakfast. So when we look at it as a whole, it's quite difficult for us because we have to do many tasks in order to make us a breakfast. So in order to make it simpler, we will break it down into smaller subtasks. So such as, first we will break it down into making the toast and making the tea. So making the toast, we have to break down into even more smaller problems on how do we make this toast. So we will have to slice the bread. Then after that, we will have to toast the bread, and we will have to spread butter, and we will need to add jam. So by looking at the smaller problems, we can see that it's actually quite easy to solve, such as slicing the bread, toasting the bread, and putting on butter on the bread and adding jam. And also similarly for making tea, by breaking it down, we will have to boil the water, brew the tea, and also add milk. And after we did this simple step, we can make a tea. And after doing the making toast part, we are done with the toast. And finally, with the toast and the tea, we are able to make ourselves a breakfast. So let's take a look at another example. Solving the crime with decomposition. Look at the picture carefully. The picture on the right. A crime has been committed and a diamond has been stolen. How could this complex problem of the committed crime be solved by breaking down into simpler problems that can be examined individually? So I will give you guys around 2 to 3 minutes to think, how can we decompose this complex problem? Okay, I'm sure everyone have a rough idea of how to further decompose of the this problem to solve the crime. So let's take a look at this picture. So after I decompose it, we can see that from here, the poster, we can tell that there's a similarity between the thief in the poster and the thief who committed the crime. And there's a time which can tell us what time this crime has been committed and the location of the crime that has been committed. And the crime scene, the witness, and also the footprint we can take, it acts as an evidence. So by combining all these decomposition, all these clues after we decompose, we can easily solve the crime. So now is a 5-minute eye break from what we have went through, which are the algorithm and decomposition. So after the 5-minute eye break, Boonhao will continue with what is abstraction and pattern recognition.
Don't you wanna play the music?
Okay, so the 5 minutes break is up. Okay, so let me begin my presentation. Can you see my screen? Yes.
Yeah, we can see it.
Okay, so the third computational thinking is abstraction. So what exactly is abstraction? Abstraction is the process of certain details and showing only essential information to the users. This can help to handle complexity by hiding unnecessary details from the users. Now, let me use a black box as an example. We don't know what is inside the black box and only know the output. Similarly, when coding, some problems may require us to use a specific algorithm to help us solve the problems, but do not need to ask to understand the algorithm in order to know how to solve them. In this case, we can code without knowing what the algorithm does, and this will save us time as we will not need to spend time to understand the algorithm unnecessarily. Now, let me go through real-life applications of abstraction. First, let me ask you some questions regarding the coffee machine problem. What is the task of the manufacturer of the coffee machine? What's the task of a barista and the user of the coffee machine? So can you draw some similarities between these roles to abstraction? You can write down your comments you can write down your answers in the chat. Yep. So if you know the answer to this, you can just write in the chat. Try to draw some similarities between the roles here and the abstraction which I talked about just now. Wait. Okay, so okay, it seems like I can't really access the chat now somehow. So okay, I'll just briefly talk about how these roles will link to the abstraction. Oh, okay. Well, so yeah, so since no one is answering, I will just say. Okay, so as you know, for the manufacturer of the coffee machine, his role is to basically just manufacture the materials needed to build the coffee machine. So he don't know what the coffee machine do, and he don't know how exactly it's gonna function. But he just need to prepare the materials required to build the coffee machine. Similarly for barista and the user. So barista, he wouldn't know how the coffee machine would function, but he only knows how to prepare a coffee using the coffee machine. And also for user, they also doesn't know how the coffee machine operate. So, but by selecting maybe selecting an option to select a specific coffee, they can get the coffee that they want. So basically similar to abstraction, we probably do not know what the algorithm does or how the functions even works. But all we need to know is what output they are expected to provide us. Yeah. Okay. So moving on to the next example is encryption. Encryption is used to protect information from being hacked or intercepted by third parties. For encryption, you wouldn't be able to see the algorithm, but by inputting the information which you want to send to another person secretly, the data will be encrypted. After you send the encrypted data to the person, you can use the key to decrypt the data and see the decrypted message. So now you can send information to other people while preventing any third parties from accessing the information. Now, I will go through a brief example of abstraction. As you can see, it's just using this code is just using a function with a hidden algorithm to encrypt and decrypt the message. So of course, you will need a key as well, as you can see in the brackets. So as you can see from the output, the encrypted message is some letters and numbers and whatever. And if you have a key, you can use the decryption function to get the message you want. Okay, so now let me share with you an actual example of how it looks like. So you can see from this in this website, it's called Formulate. So basically you can see here that there is encryption and decryption function. You don't know what the algorithm does. As you can see, I just call the encrypt function here and basically return the encrypted message, and same applies to decrypted message. So in the main program, you can see that the message I put is hello world, and this is the key which I generated. Yeah. So here this code will give me the encrypted message, which I will show you later, as well as the data type. So let me just run this program. Okay. As you can see from the program, the output here, the key is this thing. This, and the data type is actually of this encrypted message as well as the key is actually bytes. They are a form of data processed by the computer, and we don't really need to know what is it. Yeah. And as you can see here, the message to be encrypted is hello world. And after I decrypted the message, I get back the same output, the same message, which is hello world. So if once you have the key, which is here, which is this this key, the person you want to send the message to can use the same key to get the decrypted message. So basically, we don't know what the algorithm does for encryption and decryption, but we do know that the encryption function and the decryption function will return the output here as expected. Yeah, okay. So let me just go back to the slide. Okay, can you see the slide? I think can, right? Okay, so moving on to the next and last computational thinking. Pattern recognition involves finding the similarities of patterns among small decomposed problems that can help us solve more complex problems more efficiently. Some real-life examples of pattern recognition include license plate recognition, fingerprint analysis, face detection verification, and voice-based authentication. So these are the more advanced implementations of pattern recognition which you can learn in university if you take computer science. But for this session, I will take you through a simpler example of the pattern recognition, which is multiplication. So as you know, for multiplication, 2 times 2 equals to 2 plus 2, which is equals to 4. So once you recognize the pattern for multiplication, you can do a for loop to add x for y number of times. So you can see from the code, I assign 0 to the variable total and do a for loop to add x to the total, and then I return the total. So this will give me the value of the multiplication of x and y. So pattern recognition is a very useful concept because if you can spot a pattern in the problem, it can help you solve. It can help you reduce the amount of code and make your algorithm more efficient. So let me show you the next example, which is NPR. So you can see in the comments here, NPR is equals to n factorial over n minus r factorial. So you can see that I initialize n factorial and n minus r factorial as 1, and I do a for loop to get n factorial. So if you don't know what factorial means, it means that for example, if you for example 5 factorial will give you 5 times 4 times 3 times 2 times 1. So basically n factorial will give you n multiplied by n minus 1 times n minus 2 all the way until 1. Yeah. So yeah, so you can see once I get n factorial and n minus r factorial, I can return the output of n factorial over n minus r factorial, which is NPR. Okay. Now let me show you how you can make the algorithm more efficient by recognizing the pattern of in the NPR. So if you can see from the previous slide, NPR equals to n factorial over n minus r factorial. So so in this fraction there is only multiplication and there's no plus or minus, which means that if you can simplify it into this formula where NPR equals to n times n minus 1 times n minus 2 all the way to n minus r plus 1. So by doing so, you can see that we can reduce the amount of code by a few lines and make it much more simpler to understand, and as well as make it more efficient. So you can see from here, I did a for loop from n minus r plus 1 all the way to n. Yeah, and then after I return the num, it will give me the same output as the previous algorithm, but this time it will be more efficient. And yeah, so now Prakash will go through the next part of the next part on the Fibonacci sequence, which is also related to pattern recognition and decomposition computational thinking. Oh.
Okay, can you hear me?
Can louder a bit.
Okay, can you hear me right now? Is this loud enough? Okay. Okay. So, okay, I'm Prakash, and I'll be continuing with the Fibonacci sequence, and I'll be explaining to you how abstraction, pattern recognition, and finally the algorithm will be displayed through this Fibonacci sequence question. So before we continue, I'd like all of you to be familiarized with this platform called Recursive. And Bunhao, could you help me share screen so I can illustrate to them how to operate this platform?
All right, okay. Prakash, can you speak louder a bit? Yeah.
Right.
Okay, so
okay. Bunhao, can you open a new Recursive?
oh, you have a sec. Open.
The Fibonacci sequence is a series of numbers ordered as such that each successive number is the sum of previous two numbers.
Oops.
Okay, so once you go inside Recursive, there'll be this icon called Python plus Python. So you create the Recursive by entering the title, as what Bunhao has just done. And once you go in, you will see this interface. Okay, hold on, it's loading.
Prakash, can louder a bit? Yes. Yeah.
Okay, so you will see this interface right here, and in this interface, right, you have this okay, in this interface you will see this part where you can run your code, and once you click run, okay, Bunhao, can you write a simple statement print hello world? Okay, guys, before I continue, can I just request that all of you can help to increase the volume on your laptop because I may be a bit soft. Okay. Okay, so as Bernard has done, he has printed the hi at the console right there. So later on, we'll be doing a few questions in your breakout rooms. And while you're doing these questions, I would like you to also do another thing. So after you've done attempted these questions, as you can see in the top right-hand side, there's a plus icon with the invite, as Bernard has just clicked right now. Okay, Bernard will do click on it. Okay, then after you have invited, you can generate a join link, which is all the way at the bottom. And once you have done so, you just have to copy this link and send it in the Zoom chat once you have finished your program or after the time is up. Please do remember to send this in the chat, and facilitators, please ensure that they do it. Okay, now you can go back to the slides. All right.
In the sequence. The first term of the Fibonacci sequence could be considered to be either 0 or 1, and the second term is 1. Here the sequence starts with 0, followed by 1, and therefore the third term is the sum of the first and second terms of the sequence. Likewise, the series proceeds. The pattern by which nature is ordered is truly amazing. It is fascinating to see how often the Fibonacci sequence appears in nature.
Okay, I hope you all understand what the Fibonacci sequence is. And after this, you all can just watch a quick video on the nature and how Fibonacci sequence is found in real life. Okay, next slide. Sorry, previous slide. Facilitators, you can answer the questions in the chat if yeah.
Its importance is revealed in where we find it. Take, for example, the sunflower. The display of its florets are in perfect spirals of 55, 34, and 21, the sequence of Fibonacci. The fruitlets of the pineapple create this same spiral based on the sequence. The pine cone does the same. As currents move through the ocean and the tide rolls onto the shore, the waves that bring in the tide curve into a spiral that can be mathematically diagrammed onto a plot at the points 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Buds on trees, sand dollars, starfish, petals on flowers, and especially the nautilus shell are formed with this exact same blueprint. With each segment of growth, the nautilus adds to itself one more value on Fibonacci's scale. This blueprint can be seen around us on a small scale every day, but the greatest example of all is directly above our heads. At an average of 100,000 light years across, even the spiral of the galaxies above us are formed with the exact design that the tiny shell is formed. This sequence or blueprint appears to be the trademark of a designer. Its importance is revealed in where we find it.
Okay. Okay, now that you have seen the video, now I'd like to do, we're going to do a 15, 10, 5 countdown challenge. And in this 15, 10, 5 countdown challenge, we're going to be introducing the iterative Fibonacci sequence. So read this problem statement carefully. You'll be awarded 100 points, which means that when you go into each of your breakout rooms, right, you'll be points will be allocated based on your code and what you submit to us through the Zoom link. I mean, not the Zoom link, in the chat, through the repair link. And later on, we'll be awarding points, and you can see the leaderboard rankings will get updated as well. Okay, so this is the iterative Fibonacci sequence. Next slide. Okay, so now your task is to code out the iterative version of the Fibonacci sequence, where the input is a positive integer denoted by n. It is represented by the term number of the Fibonacci sequence. Your output will be the nth term of the Fibonacci sequence. So essentially what this means is you'll have a function, and this function will take in the value n, where n is the input, the term number of the Fibonacci sequence that the user wants to find. And once he has found this, once he feeds this value of n into the function is meant to return an output, which will output that term of the Fibonacci sequence. So you're going to spend about 15 minutes in your breakout rooms to code this out. And one person will be sharing a screen where you can code on Python referral, and the rest of the people will be contributing to your code. All right. So now can I request the organizers to split them up into their breakout rooms.
I'm opening the breakout rooms now, so everybody please accept. Thank you. Hello, 1 second, yeah. Please accept your breakout room invitations. Are you guys in any breakout rooms? Please accept, thank you.
Okay, welcome back from the breakout rooms. So we'll just wait for a while until everyone has left the breakout.
Okay, well, I think everyone has left their breakout rooms, right?
Wait, I will share the screen in a moment. Can you see the screen?
Yeah. Okay. All right. So all of you coded out this Fibonacci sequence iteratively, right? And okay, I'm pleased to share that I think two of our groups, correct me if I'm wrong, Sunsi's group and my group, we managed to solve the Fibonacci sequence problem iteratively. Good job. So now I'll be asking some of you to share your answers and your thought process when you're doing this problem. So could you go to the next slide first, please? Okay, sorry. Go back to the previous slide. My bad. Okay, so could I get okay, my group? Okay. Okay, so the person in breakout room 4, could you please share the solution to everyone? Well, now can you open the repel in the chat? There's one repel in the chat. Share screen and share the repel, please. Thank you.
Where?
The only thing I could think of is A plus B, no, B equal to A plus B, and then, no, wait. A plus B equal to C, then C become the new B, while B become the new A, then repeat it again and again until infinite loop.
Okay, you somewhat managed to solve it. Okay, may I know your group name, like team name? I think he was in team 3, right? Okay, correct me if I'm wrong. Okay, so he was actually somewhat correct. His loop is condition is actually incorrect, but the body is actually somewhat correct. And that was what we were expecting. As for the condition, could I, Bunal, could you share the referral I sent earlier?
No, I can't find it.
Okay, sorry, give me a second. Okay, I sent it right now. I just sent it.
Okay.
Okay, in the meanwhile, can I request, Sansi, can your group share your answers as well, your solutions as well?
My group is Junhong solved individually. He sent his code in the chat box via Zoom, in the Zoom chat box.
Could you send it again? Because I don't think we received it. Okay, yeah. As you can see, can someone from team 4 explain your code here? Could I get the person who coded it out?
Yeah. Okay. Do I say?
Yep. Do explain. If you understand it, do explain what is going on each of your lines.
So n will be the positive integer that you want to input inside. So like once you input the n, the integer, you need to say n equals to integer. This will tell you that, and this will tell the program that it is this string. So you know your first is a, which is 1, and then your second term will be b, which is also 1. So initially 0, n for this part, the range. But since your first and second term is 1 and 1, you will start from 2. So you'll be range from 2, n. So for I in range 2, n, so a, b equals to b, a plus b, which is the sequence, the previous sequence is a, which now become b, and then your present sequence, which is b, become a plus b, which is what the Fibonacci sequence is. Right? So I'll print out the current sequence, which is b. Yeah. You get the answer.
Okay, good job, good job. Okay, Tansi, could you help me add the leaderboard? Add 100 points to the leaderboard for team 4. Okay, and now we have team 9, right? If I'm not wrong. Yeah. Wait, Tansi, your team is team 9, right?
Sorry?
Your team was team 9, right?
Yeah, my team was team 9.
Okay. Junho from team 9.
Junhong, yeah.
Junho. Okay, could you share your solutions? Guys, you can refer to the chat for the solutions.
So for my solution, I decided to use a function And I define the first Fibonacci number to be 0 and the second one to be 1. And what I'm doing is I'm storing A to be a smaller Fibonacci sequence, the number, and the B to be the larger Fibonacci number, which is right after A. And for the first two Fibonacci numbers, I'll just use a simple if statement to just return it because it's defined. And for the Fibonacci numbers bigger than that, I will use the algorithm, which is where you add the previous two numbers. So for my algorithm, I do it such that it iterates through a for loop, and it'll store A plus B into A, and then it'll swap the numbers from A and B. So it's similar to the previous code, and then I'll return A at the end of the for loop.
Okay, very good. I think that solution was well done as well. Really well done. In fact, very clean as well. And you managed to solve the problem. That's the best out of all of it. Good job, Santi and your team.
Actually, when n equals to 1, it should return 1 instead of 0. I believe.
Okay, yeah, the way he coded it out is using Fibonacci sequence starting from 0 and 1, where n equal to 1 and n equal to 2. Both ways are also correct. It truly depends on what the question asks. And since in the question I wasn't specific enough, this is also a solution which is accepted. Good job. Your team earned yourself 100 points. Okay, well now you can continue to share your screen on the slides. Continue. Okay, next slide. Okay, so this is the solution to the problem, and as most of your friends already identified and solved it, here you go, the solution. You can just take a picture or go back and internalize it. In this question, I didn't really specify or didn't really state the values for if n equals to 1 or n equals to 2. But otherwise, this is how you solve it. Okay, next slide. Okay, now let's ramp up our difficulty a bit, shall we? Now, we want you to code the recursive Fibonacci sequence. Some of you might find this a bit easier than the iterative, whereas some of you might, struggle here and there. So this is a 200-point problem. So read the problem statement carefully. Next slide. Okay, some of you are quite unsure about the question earlier, right? So maybe this time, try to look at the question more thoroughly. This is the recursive Fibonacci sequence, and your task is to code out a recursive version of the Fibonacci sequence, where n is the input, and it will be positive, of course. It represents the term number of Fibonacci sequence, and your output should be the nth term of the Fibonacci sequence. All right? Spend about 10 minutes to work on this in your breakout rooms, and one person will do the sharing of the screen just like earlier, and we can split them up into their breakout rooms right now.
Hello, Adeline. How may I help you? Are you able to join your room?
Oh, sorry, I accidentally left it.
Okay, yep. You can press at the bottom, there should be a breakout room, and then you can join it back.
But actually his mic is not working, so he can only text in the chat box.
All right. Okay. Okay, in that case, Sansi, could you help me check if their code is all correct? Like for the repels they sent, and update the team scores respectively.
Okay.
In the meanwhile, it's okay, Bunha, I don't think we'll be sharing their repel. We can, since we're running out of time, we can share the solutions to the recursive problem. Okay. Okay, hope you all had a fun time solving the questions. Now I'll be showing you a quick video which I have recorded earlier to go through exactly how to solve this problem. And please do listen carefully, especially if you weren't able to solve it, because at least you would be able to learn something new through watching it. Thank you.
Hello everyone, hope you're having a good time in the Computational Thinking workshop. Now I'll be going through the concept of recursion and giving you a quick recap of what you've learned in the Python workshop. So recursion is a method of programming where a subroutine calls itself 2 or more times within that subroutine itself. And there are a few merits and demerits of recursion. For now, we'll focus on this merit of recursion, which produces neater code, lesser lines of codes, where the demerit of recursion is that it is generally slower.
Sorry, Bernal, can you
harder to
increase the
visualize
quality?
some code. Okay, hi everyone. So now we'll be continuing with the Fibonacci recursion solutions. And to find the Fibonacci recursion solutions, I'll be introducing a few terminologies and walking you through the whole idea. So first, let's consider the sequence 1, 1, 2, 3, 5, 8, and that is the Fibonacci sequence. And the term number n is illustrated right below the phrase consider sequence. So we have the terms 1, 2, 3, 4, 5, 6. So now the question wants us to find the value of fib n, right? And let's say the value of n is 6, and the question wants us to find fib 6, basically. Okay, so to find the value of fib 6, what a human like us would do is we'll start from over here, right? And we'll be like, okay, the first term, okay, 1 is a fixed term, 2 is a fixed term, and now we look at the third term. And the third term will basically be an addition of first term's value and the second term's value. And so we can compute the third term. So the fourth term will be the addition of the second term's value and the third term's value. Similarly, the fifth term will be the addition of the third term's value and the fourth term's value, and so on, until we find the Fibonacci of 6. So, is there an easier way of coding this out? Like, instead of such a complicated algorithm, can we make it simpler? And the answer is actually yes. Well, not really simpler to understand, but simpler to code it out. Alright, so what do we do?
Sorry, Bernal.
As a computer,
Could you make it full
sorry,
screen?
I actually need to erase this. 2, 3, 4, 5, 6, right? Okay, so as a computer, we can start from the back and compute our way to find the Fibonacci of 6. So, what do? So we start at Fibonacci 6, and we can call Fibonacci 4 and Fibonacci 5. Okay, and why do we do this? Because we know that Fibonacci 4 plus Fibonacci 5 will give you 8. Fibonacci 6, 3 plus 5 equals to 8. So, what we're essentially doing here is we're breaking down the problem of Fibonacci 6 that we're given, which is an arduous task, into 2 smaller problems. And so, we can call these smaller problems. Okay? And this is the bigger problem in this level. And so, we can continue on. Fib 4 will give me Fib 2 plus Fib. Let's just make more space. Let's spread it out a bit more. Fib 2 plus Fib 3. And similarly, Fib 5 will split up into Fib 3 plus Fib 4. Okay, well, you can fact check this. Fib 3 plus Fib 4 will give you 2 plus 3, which will give you 5, which is Fib 5, that's correct. And similarly, Fib 2 plus Fib 3, which is term 2 plus term 3, 1 plus 2 is equal to 3, and that is Fib 4. That is correct. And now we arrive at Fib 2 over here, right? Okay, let's ignore this for now. Okay, we'll come back to this later on. For Fib2, for Fib3, we can still break it down into Fib1 and plus Fib2. And similarly again, another Fib3. Okay. And then we can break this guy down into Fib2 and Fib3. Okay. Now we can actually have to split up Fib3, and Fib3 can be split up even further into Fib2 and Fib1. Okay, and okay, let's just write down which are the smaller problems. So as you can see, almost everything except for this one here is all the smaller problems, right? And so what exactly is this Fib2 here called? We haven't solved this, right? And if we were to branch Fib2 out into two of its components, it will be Fib0 plus Fib1. But that doesn't make sense, right? Because the 0th term is not a term in the Fibonacci sequence. That's an invalid term. So what do we exactly do with this Fib2? Well, I think at this point, we shouldn't overthink, as Fib2 is essentially a known value. It is actually equal to 1, right? Because the first two terms of the Fibonacci sequence are always fixed at 1 and 1. So what we can do is we can return 1 over here. 1, okay? To make it less messy, I'll just put a 1 with a circle, right? And what this is called is the smallest problem, okay? Or we can call this the base case in recursion terms. So now that we can find all these smallest problems, where Fib1 is also the smallest problem, Fib2 is also the smallest problem, Fib1, Fib2, Fib2, Fib1, Fib2. All these are actually smallest problems. And we can return 1 because the first term is also a 1 and the second term is also a 1. So we can return 1. Return 1. Return 1. Okay, so now that we return 1, how can we compute Fib3? Fib3 is essentially the addition of Fib1 plus Fib2. And we know that Fib1 and Fib2 is equal to 1 and 1. So 1 plus 1 is equal to 3. Sorry, so 2. So we return 2 here. Okay, and over here we have 1, right? So we can have Fib4 is equal to Fib2 plus Fib3, and that is 1 plus 2. We have 3. So this Fib4 will return 3. Now let's look at the right hand side of the whole picture. Okay, so we know now that Fib1 here and Fib2 both return 1. And we know Fib3 is Fib1 plus Fib2. So Fib3 is 1 plus 1, which is equal to 2. Fib5 gives rise to Fib4, Fib4 gives rise to Fib2 and Fib3. Fib2 returns 1, Fib3 splits up further into Fib1 and Fib2. And we have Fib1 and Fib2, which return 1 each. Fib3 now returns 1 plus 1 equals to 2. And now that we have Fib2 and Fib3, we can add them up to form the bigger problem, which is Fib4, which is 1 plus 2, 3. So Fib4 will return 3. And Fib5 will now have Fib3 and Fib4, where Fib3 plus Fib4 gives rise to Fib5, which is essentially 2 plus 3, which is 5. So Fib5 returns 5. Now we can return, once again, Fib6 is Fib4 plus Fib5, which is 5 plus 3. That will return 8. And now we have finally returned all our values. And Fib6 basically returns 8. Now let's check. Does Fib6 actually equate to 8? And yes, it is. And there we go. This is our recursion tree. And this is how the recursion works for a Fibonacci sequence. Hello everyone, hope you're having a good time in the competition.
Bruno, I think there was one last part in the video that you might have missed out. It's nearer to the last part. Yeah, it's at 9:30. 9:30. Okay.
One or two, where it will be if n is equal to 1 or n equals to 2. Next, we have to formulate a recurrence relation. Okay, don't be scared of this word. It is simply a pattern that we have to find in this whole sequence. And the pattern will help us formulate our smaller problems. Okay, the smaller problems. And this recurrence relation can be derived by this formula that we have used previously. And there we have it. These are the 3 key steps to solving almost any recursion problem. As once you formulate them as this 3, you're able to put it out and solve the problem and be able to visualize it. I hope you understand solving of the Fibonacci sequence. Thank you.
Okay, I hope you enjoyed the video that I have made just now. Okay, now let's run through the solutions, the recursion problem. And in line 1, you can see that there's a function being called, the Fibonacci of n. And after the function is being called, we check line 2 is the base case, so which I explained earlier in the video. A base case is when n is equal to 1 or when n is equal to 2, because the first 2 terms of the Fibonacci sequence would always return 1, right? And your 6th line will be otherwise. Your recurrence relation exists in line 7, where it's the general case where a smaller problem will be formulated through calling fibn-1 and fibn-2. If you had listened and sit through the Python workshop, you should be able to understand this base case, smallest problem, and smaller problems. Okay, next slide. Okay, there's this next problem called the faster Fibonacci sequence. And instead of asking you to go out to breakout rooms and solving this problem, I'll give you all like around a minute to think about this. And right after that, I'll be discussing the solutions, because this problem is pretty, it's a bit non-intuitive and it's a bit tough. So using the recursive Fibonacci sequence that you have just coded out, can you identify some sort of pattern or unnecessary function call in our recursion? And how do you intend to solve these repeated operations? So just think about it for a minute, and I will move on to the next slide. Okay, so did anyone manage to figure it out? If you managed to figure it out, put your hands up. Then we can see that you're smart. Anyone manage to figure it out? Anyone wants to share their solutions? Okay, I don't see any hands up, so all right. Okay, next slide. Okay, I'll just share the solutions with you. Okay, suppose you have a 5-minute eye break, but let's just continue. Okay, so as you can see, the function called fibn starts by calling its subordinates fibn-1 and fibn-2. And as you can see, the function calls actually are repeating, where fn-2 is repeating in 2 instances, fn-3 are repeating in the red portions, text in red. And this incurs in such a long complexity and it's very slow. So could we actually make this faster? Okay, so Yes, actually it's
negative at 3 or 2 equal to a unit where it's a variable so that you can change it for all the methods.
Sorry, I couldn't catch you. Could you repeat?
Change the 3 or change the negative into you can minus a variable so that it could be changed at any so that it will be easier.
Okay, that's actually a good idea. But the solution that I have at hand right now is that actually I'll go about and think about your solution later on. But the solution that I have prepared for you all is storing all these function results to this function call in an array. Okay. Okay, for now, I won't be explaining to you how I'm going to be storing in an array. You can go back and think of it as your homework. All right, next slide. Okay, I'm supposed to be doing a live coding, but once again, you can try coding it out at home and trying out this problem. If you have any problems, you can just go into the Discord channel and ask us. Okay, so let me illustrate to you how each of these computational thinking came in the early examples, like you spend an hour or so on, right? So in question 1.1, when you coded out iteratively, you had an algorithm where it iterated from 0 to n, has two variables to store the previous two numbers, and you update it as you go by the Fibonacci sequence, right? And there we go, that was the algorithm. And this process repeated. In aspect 2, decomposition was also emphasized in our computational thinking. It's one of the aspects of computational thinking, which is illustrated through question 1.2, where in your Fibonacci sequence, there was a recursive separation of functions and calling of functions. Fib5, as you can see in the diagram, called Fib4 and Fib3, and each of these called many different functions respectively. And the problem of Fib5 is being decomposed into Fib4 and Fib3, and the problem of Fib4 will be decomposed into Fib3 and Fib2. So you can see this decomposition is basically something which applies to almost all recursion problems, and is not only applied in recursion problems, but when you're thinking of a solution to a problem in computer science, you basically think of decomposition. And it's a very useful and important key aspect of computational thinking. Next slide. Lastly, we have pattern recognition. And this was illustrated through question 1.3, which I briefly went through. So a pattern was identified when we identified the repeated operations, where the repeated function calls, and we did something to solve this problem, right? The thing I was talking about, arrays. So we try to mitigate these repeated function calls to make our program faster and then run faster. And in computing, we always want to achieve the fastest and the most efficient use of resources. Next slide. Okay, now we've reached the conclusion of passing the time to Poon Hao to explain and summarize the things we went through today.
Okay, so we have gone through the 4 computational thinking, mainly the algorithm, decomposition, abstraction, and pattern recognition. So for algorithm, we have talked about how the steps as well as the order to the algorithm are important. We also learned about the different approach, such as the brute force approach and the divide and conquer approach. Chen-Si has previously explained using the phone book example. So for decomposition, we talk about how to decompose a problem into smaller subproblems to solve a larger problem. This is often seen in recursion, which Prakash has shown you just now using the Fibonacci sequence example. So for abstraction, we ignore what the algorithm does if there is no need to, and we only need to care about the output. So I've used the encryption and the coffee machine example to show you the abstraction. So actually, for the coffee machine example, what I said earlier wasn't exactly right. So the manufacturer. So actually, the manufacturer needs to know the internal workings of the machine as he's the one building it. So maybe in this case, manufacturer will be the only person who will know what the machine does. Yeah. And the user only need to know the functions available, but not the internal mechanics. So they only need to press the button for let's say a black coffee or I don't know, some coffee, and then another button for maybe another coffee. So so to the last computational thinking, which is pattern recognition. Basically, I've gone through with you that once you can see the trend or pattern, it will help you to improve the efficiency of the code and help you solve the problem. And I've used the NPR algorithm as well as the multiplication algorithm to show you the example. So lastly, Prakash has also explained to you the solution to the Fibonacci sequence. So that's it for our session.
Okay, sorry to interrupt, but I see that a lot of you are confused or may not understand our workshop, and that's perfectly fine because you are all in this together. And I heard from a few people that they're a bit confused. So we have actually uploaded the slides on the Google Drive. We'll be sending the link to this Google Drive tomorrow on the Discord channel. So keep an eye on that. Also, hope you had a great time. Now we'll be passing time to Elston. He'll be doing a quick debrief. Thank you.
Okay, thank you, Bunhao, Junsi, and Prakash for that workshop. Anyone else has some last questions for the speakers? You can put them in chat and the speakers will answer them. Thank you for hosting this workshop, Prakash, Bunhao, and Junsi. Moving forward, if any of you here are interested to join us as organizers, please sign up on the link, which I'll be sending soon. You don't have to be a computing student to sign up. There's a lot to learn from being an organizer, and we have many areas to help out in. I hope everyone managed to learn something today. With that, please complete the reflection form before you leave the workshop, and we hope to see you again. I'll be sending the organizer links real quick. And please complete this form before you leave the workshop. Thank you.
Oh, yeah. Before we end, also I'd like to update you all on the player rankings and which team breakout team has won today. So good job, Team 4, Team 9, and Team 10. Team 4 placed as the first place, second place was Team 9, and Team 10 placed at the third place. Good job to all of you. Okay, can I know the names of those people in those groups so that we can, if there will be prizes, we can award them to you all. Can those in Team 4 say your name out loud? Hello, it's prizes.
My name is Pei-Jun Yi.
Pei-Jun. Okay, from Team 4, right? Okay, anyone else in Team 4? Last call, Team 4, free gifts. No? Okay. Then as for Team 9, shout out your name.
I'm Jun Hong.
Okay. Jun Hong. Anyone else? Team 9. Team 9. Last call. Anyone else? Team 9? Okay. Okay. So the chat. Okay, you can also tick in the chat. Team 9, Team 10. Okay. Okay. Jocelyn was Team 9. Okay. Then Joy Ping was Team 10. Okay. If there's no one else, you all can leave this Zoom. I think Elston is done with this debrief. Thank you for joining us today.